no more questions, we can move to the next speaker. On behalf of Dr. Esposito from Ferrara, there will be her PhD student, Laura Ravani. Laura Ravani has a degree in pharmacy with magna cum laude at the University of Ferrara, and since January this year attends the first year of doctorate in pharmaceutical sciences under the supervision of Professor Menegatti. And today she will talk about solid lipid nanoparticles for the delivery for the Parkinson therapy. So please, Laura. Thank you.
Thank you for your introduction, and good morning to everybody. What I'm present to you is a formulative study for the development of a new drug delivery system for bromocriptine, BK. So, solid lipid nanoparticles are aqueous colloidal dispersion of lipid-based particles having a diameter comprising between 50 to 500 nanometers. In our study, we choose solid lipid nanoparticles because they have various advantages, and in particular, they are made by natural and biocompatible components. Their preparation doesn't use organic solvents, and they are able to improve the solubility of insoluble molecules. So we thought that SLN encapsulation may represent a novel strategy to obtain stable plasmatic levels and an increase of the drug half-life. Parkinson's disease is a progressive neurodegenerative disorder characterized by a dopaminergic deficit. And BK, which is a dopamine agonist, is used in the treatment of Parkinson's disease. BK shows a slow onset of action and a prolonged half-life, but it has also a poor oral bioavailability, about 6%, and so it requires 3 daily doses. So we asked ourselves, could SLN change pharmacokinetics and or pharmacodynamics properties of BK? And we started our study with the production and the characterization of solid lipid nanoparticles. Then we analyzed the morphology and the dimensions. We analyzed also the BK encapsulation efficiency, and we did the X-ray diffraction measurement. Finally, we studied the in vitro release kinetics of BK, and we evaluated the antiparkinsonian activity of free BK and BK encapsulated in SLN in a rat model of Parkinson's disease. SLN were produced in 2 steps. In particular, in the first one, the melting lipid phase was added to the aqueous solution, and then after an high-speed stirring, we obtain an emulsion. In the second step, the emulsion was subjected to homogenization or to ultrasonication, and in both cases, we obtain SLN. SLN were produced using different lipidic solution, as you can see in the table. And finally, we obtained that the optimal condition were the use of the ultrasonication method, a lipid composition made by pure tristerin or an association with tristerin monosterin or tristerin tricaprin, and a lipid concentration of 5% weight. Then we characterized SLN using PCS, and we did analysis immediately after the production and by time. The results show that the mean diameters are comprised between 160 nanometers and 345 nanometers. but in particular, the best formulation was the one made by tristerin-tricaprin because by time it showed the lowest mean diameter and the lowest polydispersity index. Then we did the Cryo TEM analysis, and we could see that in all samples it's possible to see needle-like and ovoidal structure depending on the edge viewed. But in particular, in the panel of the tristerin-tricaprin formulation, it's possible to see that the needles respect the SLN side views are more elliptically shaped. And this may be due to the presence of tricaprin, which is liquid at room temperature, and so it forms caps on the surface of SLNs. Then we produced BK containing SLN, adding the drug in the molten lipid phase, and then the homogenization method was employed to obtain BK containing SLNs. We did a characterization of SLN containing BK with the PCS analysis immediately after the production and by time. And also in this analysis, the best formulation was the one made by tristerin-tricaprin because by time it showed the lowest mean diameter and the lowest polydispersity index. In the Cryo TEM images, we didn't find differences between the formulation made without the drug and in the formulation containing BK. But in particular, in the samples made by tristerin-tricaprin, also in this formulation containing BK, it's possible to see that the presence of tricaprin, which is liquid at room temperature, creates oil droplets on the surface of SLN cores. The X-ray diffraction measurement were did on the samples made by tristerin-tricaprin. And in the high-angle X-ray diffraction profiles, it is possible to see that the presence of BK doesn't affect the scattering profiles, and so that there isn't any variation in the order inside the hydrocarbon chains, and so that BK is perfectly solubilized by the tristerin-tricaprin mixture. When we analyzed the encapsulation efficiency, we found that the best encapsulation efficiency was the one of the formulation made by tristerin-tricaprin, and so it's possible to see that the homogeneous lipid nanocompartments of NLC promote BK encapsulation rather than solid lipid nanoparticles. In the in vitro BK release kinetics, we found that the drug release was always slower for SLN encapsulated than free BK, and in particular, the slowest release was observed for NLC produced by tristerin-tricaprin mixture. So, this formulation was used in a study called BAR test to verify the anti-Parkinsonian activity in a rat model of Parkinson's disease. In panel A and B, it's possible to see the akinesia at the contralateral forepaw in panel A and the akinesia at the contralateral plus ipsilateral forepaw in panel B. In the graph, the X line showed the time and the Y line showed the time on bar. In particular, it's possible to see that both BK-free and BK encapsulated in SLN is able to reduce the time spent on bar. But the encapsulated BK show an onset of action more rapidly. In particular, encapsulated BK, which is shown in blue line, was effective already 30 minutes after the administration, and its action still close to maximum 5 hours after the administration. Conversely, the action of free BK was lower on onset of action and short-lasting, since it's disappear within 5 hours. So we can conclude that NLC based on tristerin tricaprin mixture could be proposed as an innovative system to administer BK in the Parkinson treatment, that this nanoparticular vehicle demonstrated to control BK release through the BBB, but other studies are required to confirm these preliminary findings. So.
Thank you, Laura. Thank you for your presentation. Now discussion is open to the audience. The first question is in the first line. Yeah.
I would like to ask you if did you carry out a dissolution test of the drug towards the dialysis tube? I mean, to do a comparison with the release data.
Okay. Yes, it's a good question. I think we did this study. Okay. And so you can see in the image that, yes.
Okay. Another question?
Yes. It's okay about the release of BK to the brain, but my question is, have you any idea or feeling that SLN are released to the parenchyma of brain, or they stay within the endothelium? Because you can get the same effect even if you don't need to have an active passage of nanoparticles to the brain.
Yes. So first of all, we studied here the anti-Parkinsonian activity in a first study. Then we will do these studies also to analyze these data. But so
ongoing.
It's
okay. Ongoing results. So you will improve, I think.
Yes.
Yeah, okay. Another question, maybe before. Sorry.
Do you take into account the consideration to optimize the particle size of the microsphere, nanosphere?
So could you repeat, please? So you.
I think it was asking for the improvement of the particle size, and so the technological process, if could be improved, if I correctly understand.
Yes, yeah.
So your particle size, sono diventate più, come può migliorare le dimensioni? Ha chiesto.
Or I explain better the question. Do you think to use the other technology in order to improve the quality of the particle size, maybe high pressure homogenization?
Yes, I think it will be a good method to improve the dimensions of SLN. But for this moment, we did only this method, and we obtain, I think, good results. But maybe in the future we could try to produce SLN also with other methods.
Okay, thanks.
Another question? Yes.
Only two small technical questions. One is, have you an idea of the drug loading value, the log P value, and drug loading for BK?
Well, yes, we.
Do you know it?
I didn't.
Which is the log P?
Torna indietro. Dove? Qua.
Oh. Okay. And how do you did the X-ray experiment? In which do you know in which
we didn't
state where the SLN?
So we didn't do X-ray measurement in our laboratory, but we have a collaboration with another laboratory, as you've seen in the first
you
slide.
You don't know how they treat the SLN? No.
You could read in the article that it's shown also the method of yes.
Okay. Any more question? So I have a question very, very quick. How many animals do you use for these tests?
About 6, 7
Okay.
for
Any group?
Any group, yes.
Okay, thank you.
Okay.
Thank you very much.